Welcome you all. In this session, we are going to discuss the constructional details of induction machine. The two major parts of three-phase induction motor are stator and rotor. The stator consists of core and winding. Similarly, the rotor also consists of the core and winding. So first, let us discuss in detail about the stator. Construction of stator. The stator is built up of high-grade alloy steel laminations to reduce eddy current losses. It has three major parts, namely outer frame or yoke, this stator core and stator winding. First, let us discuss about the outer frame or yoke. It is the outer body of motor. Its main function is to support the stator core and to protect the inner parts of machine. For small machine, the outer frame is casted, but for large machine, it is fabricated. So this is the diagram of stator. So stator, you can see the stator stamping tooth as well as the slots. So Stator core. The stator core is built of high-grade silicon steel stamping. Its main function is to carry the alternating magnetic field which produce hysteresis and eddy current losses. The stamping are fixed to stator frame. Each stamping are insulated from other with thin varnish layer. The thickness of stamping usually varies from 0.3 to 0.5 mm. Slots are punched on the inner side and the stamping are shown in figure. So in the previous figure you might have seen the stator core stampings, slots, and next is stator winding. The core of the stator carries three-phase winding which are usually supplied from three-phase supply. The six terminals of winding are connected in the terminal box of machine. The stator of motor is wound on a definite number of poles depending on the speed of motor. So the poles, it depends on the speed. They are interrelated. So with the help of the expression given below, you can relate the number of poles and speed. The synchronous speed ns is equal to 120 f by p. That is, they are inversely. If you need to improve the speed, then number of poles need to be minimized. So if the number of poles is greater, the speed of motor will be less, and if the number of poles is less, then the speed will be high. So with the help of this relation, you can relate the speed and number of poles. So here comes the rotor construction. The rotor is also built of thin laminations of same material as that of stator. The laminated cylindrical core is mounted directly on shaft. These laminations are slotted on outer side to receive the conductors. There are two types of rotor in case of induction machine. So based on rotor construction, it can be classified into two. One is squirrel cage and other second one is wound rotor. Squirrel cage and wound rotor. First, let us discuss about the squirrel cage rotor. A squirrel cage rotor consists of laminated cylindrical core. The circular slots at the outer periphery are semi-closed. Each slot consists of uninsulated bar conductors of aluminum or copper. At the end of rotor, the conductors are short-circuited by heavy ring of copper or aluminum. So here you can see the squirrel cage. The name squirrel cage is all because it resembles like a cage of squirrel. So we call it as squirrel cage. And one more thing to be noticed is the always it won't be, the bars are slightly in an angle. It's we call them as skewing because slightly skewed. Why? Because in order to avoid curling of motor, so for that we are go for skewing. So here comes the reason why we have skewed. The rotor slots are usually not parallel to the shaft, but they are skewed. The skewing of rotor conductors has the following advantage. It reduces the humming and provides smooth running and noise-free operation. It results in a uniform torque curve for different positions of rotor. The locking tendency of rotor is reduced as the teeth of rotor and stator attract each other and lock. It increases the rotor resistance due to increased length of rotor bar and conductors. Wound rotor. The face wound rotor is called a slip ring rotor. It consists it can be called a slip ring rotor or wound rotor. It consists of cylindrical core which is laminated. The outer periphery of rotor has a semi-closed slot which carries three-phase insulated winding. The rotor windings are connected in star. The slip ring induction motor diagram has been represented here. See here you can see the slip rings and skewed rotor slots. Again the skewing for same reason we have skewed. In order to reduce the noise and hunting effect, we go for skewing of a rotor. The slip ring are mounted on the shaft with brushes resting on them. The brushes are connected to a variable resistor. The function of slip ring and brushes is to provide a means of connecting external resistors in rotor circuit. The resistor enables the variation of each rotor phase resistance to serve the following purpose. It increases the starting torque and decreases the starting current. It uses to control the speed of motor. In this type also the rotor is skewed. A mild steel shaft is passed through the center of rotor and it is fixed. The purpose of shaft is to transfer the mechanical power. Thank you.